So with number nine, I saw a lot of people get this wrong during the rewind. So can somebody explain to me what you would do for number 9? Guillermo?
Since it's a negative on the outside,
Mm-hmm.
do the reciprocal.
Okay.
Then you would distribute the reciprocal.
So reciprocal becomes 3 over 2, and then that whole thing is to the third power. So it'd be 3 to the third over 2 to the third. And if you simplified that, it ended up as 27 over 8. You could also do it like this, 2 to the negative 3, 3 to the negative 3, and then flip. You get the same thing. But you need to remember that if it's a negative exponent, that would flip. All right, what about 15 and 16? How do you do scientific notation, division, or multiplication? What do you do here? 2 separate problems. What are the 2 problems? Like in number 15, what's the first problem?
3.8
Divided by 1.9. And then what's the second problem? Okay, 3.8 divided by 1.9 gave you what? 2. And then it's going to be times 10. And then how do you figure out what your exponent should be? Subtract them. What's 5 minus negative 6? No. 11. Why? Because if it's 5 minus a negative, that becomes a plus sign. Okay, so those were the mistakes that I saw most people make. We're getting negative 1 instead. If it's 5 minus a negative 6, then that becomes 11. The reason for that is, look at this right here. So look at 10 to the 5th over 10 to the negative 6th. What would you do here if you weren't going to use the shortcut? What would you have to do?
You would make 10 positive.
You would make, wait, which one positive?
Bottom.
The bottom one would become positive, and then where would it go?
It would go at the top.
At the top. Does this one move? No, because it's already positive. So then you have 10 to the 5th times 10 to the 6th. And how do you do this? You add them together. So it becomes 10 to the 11th. So that's why it's 10 to the 11th and not 10 to the negative 1. It would be 10 to the negative 1 if this 6 were what? Positive. Okay, so just be careful with that when you're subtracting. If it's subtracting a negative, it becomes plus. All right, so we're going to keep moving forward in this chapter on working with really, really big numbers and really, really small numbers and a lot of exponent rules. And the reason that we were doing all those exponent rules is because we're going to use them when we're working with polynomials. And one of the biggest things we're going to do in all of this algebra is multiplying polynomials, dividing polynomials, and working with polynomials, because it all leads to factoring, which is pretty much the bulk of Algebra 1, the new stuff that you're going to learn, is factoring. And so we need to be able to manipulate with polynomials and monomials. So before we start, we need to get some vocab down. So a monomial is a number, a variable, or a product of a number and variables. So basically, it's what you would call a term. All right? So a monomial is any of these things. These 4 are examples of monomials. So we have 7. That's a monomial. It's just one term. X squared, also a monomial. 3x, this is a monomial that contains a constant and a variable. And then this right here, 12x squared y to the third, is also a monomial because it's all held together with multiplication. All right? If you have something like this, this is not a monomial because it has addition in it. All right? So this is one monomial plus another monomial. So a monomial, mono means one. All right, like monotheistic. Have you guys talked about that in religion? What does it mean if you're a monotheistic society? You believe in one God, right? So Christians, Catholics are monotheistic. We believe in one God. Monomials means there's one term, okay? So this is a monomial plus another monomial means that this would be a, does anyone know what this is? If it's got 2 terms in it, what do you think you call it?
An expression.
It is an expression, yeah. A polynomial. How many, what's the prefix for 2? Bi. So this is called a binomial because it has 2 monomials in it. What do you think it would be if I said plus y squared? Trinomial. And from there, then they're all just called polynomials. All right, you don't say like quadnomial or quintinomial. I guess you could, but we don't usually. So you go monomial, binomial, trinomial, polynomial. Anything more than 1 is a polynomial, just more specifically, this would be a trinomial. So a monomial is basically those puzzle pieces. And they can be really, really simple, like a 7, or they can be really, really complicated, like this one right here. But what keeps them together is multiplication. all right? So that's just a monomial because it's all held together with multiplication. As soon as you see this plus sign or a minus sign, it's not just one monomial anymore.
How about division?
So if you have this, what do you guys think? Do you think that's one monomial or two monomials?
Two.
All right.
No, it's one.
I'm going to argue that it's one. Because could you write this a different way?
Yes.
Yes? How else could you write 3 over 4? You could write it as 0.75. 0.75 x squared y to the third. So this is a monomial because you can write it as 1. So anytime it's held together by multiplication or division, you can consider it a monomial. Typically, you're not going to see these. We're mostly going to work with just held together by multiplication. Okay? All right, so a degree of a monomial is just basically assigning it a number that tells you how many exponents you're talking about here. So for this one, the degree of the monomial is the sum of the exponents of the variables. So it's the sum of the exponents of the variables. Essentially, the degree is telling you how many variables are we talking about here. All right, so in this monomial, how many x's are there really here? 2. Because if I wrote this out, what would it look like? X times x, so it'd be like 5xx, and then what? Y, and then okay, 5xx, y, z. All right? But I don't want to write all that out. That's long. So we condense it by using exponents, right? The degree of the monomial, again, is just how many variables do you have. So how many x's do I have? 2. How many y's? 3. And how many z's? 7. So how many altogether is that? 12. So the degree of this monomial is 12. Brendan, do you have a question?
I don't know why, but I think there's some science where like if there's like a 5 next to like a bunch of variables, you multiply the 5 with that, and I keep thinking you're supposed to do that.
What do you mean? Say that again.
So like, do you know how write like 5x 2?
Oh, squared?
Yeah, squared.
Like little 2?
Mm-hmm.
Okay.
Then you would say x equals 4.
Okay.
You would do 4 times 2, 4 squared, and then once you do 4 squared, you multiply by 5.
Yeah.
And I think I did that on the quiz.
So you would do that if I gave you a value for the variable, but since I haven't, you can't do that. So you can't just like assign a random value. It's not wrong. If I told you that x equaled 4, what you just described is exactly how you would do that. You would say 5 times 4 squared, which is 16 times 5, which is 80. Yes. So that wouldn't be wrong, but I would have to give you this to do that. Since I don't do that up here, there's nothing you can do to simplify it. That's not wrong, though. Okay, so the degree is essentially how many variables you have. So in this monomial, which is a pretty complicated monomial, we have a degree of 12. What's the degree of this monomial right here? 2. What's the degree of this one? 1. Why is it 1? It's an imaginary exponent, an imaginary 1. What's the degree of this one right here? 5. What about this one? It does not have a degree. Degree of 0. Why not? There are no variables. So it's still a monomial, but since it has no variables, the degree is 0. All right. What about A? What's the degree of this monomial? 6. Why? 4 plus 2. There's 2 A's, 4 B's, so 6 is the degree. What's the degree of B? 0. And what about C? 1. Okay? Yes, and I swear to you, every single year when I teach this, everybody's like, oh, that's it? Like, that's so easy. I hope our whole test is just degrees of monomials. And then for some reason, I think because it's so simple, people don't look at it again, and then they get them wrong on tests and quizzes. So yes, it is this easy, But don't forget that you do have to remember it, okay? Yes, that's really it for monomials. We'll talk about polynomials in just a second. But yeah, so for degree of monomials, you're basically just counting the variables. How many variables do I have? Go ahead, Brendan.
What if you have a negative variable?
Yeah, that's a good question. What do you think you do there?
I think you subtract. You switch it first. Then
Okay, give me an example. Give me a variable with a negative exponent. Like, give me some monomial.
5x negative squared over 3x.
X4. Okay. What do you think you have to do before you can figure out the degree? You've got to rewrite the equation. So what would it, or the expression? So what would it look like?
5x, or wait, no.
Yeah, 5x.
I don't agree. I don't think there would be an x on the top.
3,
5 over 3,
x negative 2.
x negative 2. Okay.
No. X 2.
Where would the x2 go? x2 would have to go at the bottom. So it'd be like 5/3 x2. Okay? So I would think that the degree of that would be 2. All right? However, I'm not going to give you those. Don't worry about negative exponents. I'm not going to give them to you unless I gave it to you like this and I said 5x negative 3x 8, and you could simplify it to 5x to the 5th, and then the degree would be 5. I'm not going to give you a negative for this unless you can simplify it out. So it's gone. But good question. Okay. So a polynomial is the sum or difference of monomials. What does sum mean? And what does difference mean? Subtract. So again, like I said, it becomes a polynomial when you add together 2 or more monomials. So here, this is a polynomial. Specifically, how many terms does it have? 2, so we call it a binomial. Again, bi like bicycle, all right? Bicycle has 2 wheels, all right? So the sum or difference of monomials. How do we find the degree of a polynomial? So to find the degree of a polynomial, you find the degree of each term and then pick the biggest one, okay? So we've got this term right here. What's the degree of this term? And what's the degree of this term? So the degree of this polynomial is 5. Okay? I'm not going to touch you, but can you just like knock it? Okay. Just relax. Here. Well, now it's like under your shoe. No, it's not a bee. No, I don't think he killed it.
I have sausage.
Is it dead? Or is it just scared?
I think it's. There's a tournament in the gym. Oh yeah, I asked you to trust me.
I'm going to go free it out into the hallway.
There's a ladybug in that.
Okay. Ooh, it flew away out there. It's alive. I didn't throw it away. I set it free. Okay. All right. So, yeah, well, now it's no longer my problem. Okay, so degree of a polynomial. Find the degree of each monomial and then pick the bigger one. So the degree of this one would be 5 because this is the largest term you have. The reason we care about degrees is because when you're writing polynomials, you need to write them in order of degree from greatest to least. So technically, this is not in the correct format because the bigger degree is second. So how could I rewrite this so it's in the right order?
18x to the 5th power.
Almost. Not negative 5. Where's the negative 18? So it'd be negative 18 x to the 5th, and then what? Plus 4x. Okay? So this is the standard, the proper way of writing this polynomial because this degree is bigger. So we write in order of biggest degree to littlest degree, and then the degree of the whole polynomial is just whatever your biggest one is. Okay? So that one is 5 because this term has the largest degree. Okay, so at your boards, 1, 2, I want you to do these 6. Before you go up there, though, no, you should be good. Go ahead and do those 6. If you cannot see them, you can come up to the board to look. So when we're talking about degrees of polynomials, the reason that we're doing it is to be able to write a polynomial in standard form. So the standard form of a polynomial that contains one variable is written with the terms in order from greatest degree to least degree. When written in standard form, the coefficient of the first term is called the leading coefficient. So I don't really care as much about leading coefficient. We're not going to worry that much about that, but I do want you to be able to write it in the correct format. So what would this polynomial look like in standard form? Again, standard form means the biggest degree to the smallest degree. So if I rewrote this in standard form, what would it look like? Which one is going to be my first term? Okay, this one will be my first. What will be my second? X2. What would be my third? 20x. And my fourth? Okay, so I have to write them, but you have to keep the signs with whatever term they're with. So if my first term is this, what's that actually going to look like? Negative 4x to the third minus x2 plus 20x plus 2. Why is it plus 20x? Yeah, there's no sign in front of it, so you assume it's a what? A positive. Good. Okay, who can come do B? Who can come do B? Ollie? Greatest to least, yep. Perfect. Y to the fifth plus y to the third plus 4y. So what's the degree of this polynomial? 5. Because the biggest degree in here is 5. Okay. When we're classifying polynomials, we can classify them two ways. We can classify them by their degree, and we can classify them by their number of terms. So number of terms, there's only 4 things you need to know. It's either a monomial, binomial, trinomial, or polynomial, because polynomial means, poly means many, so it covers anything 4 and above. Bi means 2, so binomial is 2. Tri means 3, so trinomial is 3. Okay? If we're classifying them by their degree, these are the words that you need to know. So if the degree is 0, that's a constant, which we already know that term, because if the degree is 0, it's something like, give me an example of something with a degree of 0. 2. Okay? This would be a constant. It has no variable, so that's a constant. So this would be like 2. Okay? Linear means that it has a degree of 1. So something like this, 3x. All right? That would be a degree of 1. We've seen linear because it means it's going to look like what if you graph it? Like a line. Good. Quadratic has a degree of 2. So what would that look like?
2 variables?
Not necessarily 2 different variables, but it would have at least a what power?
Second.
To the second power. So it might be something like 3x squared plus 2x plus 4. All right, that has a degree of 2 because the biggest degree is 2. That's a quadratic. A third cube or a third power is cubic. So that would be like 4x to the third plus 2x squared plus 5x plus 8. That would be cubic because the biggest degree is 3. Is this a monomial, binomial, trinomial, or polynomial? Polynomial. What about this one? Trinomial. What about this one? Monomial. And this one? Constant or monomial. It's just one term. Because you can, it's like having a pen. I don't know. It's like using the pen. It doesn't know the difference between the pen and my finger. What? Yeah. Mm-hmm. Just this one, though. The rest of them are normal. Okay. Quartic means it would have an exponent of what? 4. Quintic would mean it'd have an exponent of what? 5. And anything more than that, they stopped making up prefixes for and just say 6th degree, 7th degree, 8th degree. All right. I'm going to tell you right now, I don't really care about any of them except up to here. Okay? I don't really care about any of them except up to there. Because we're not really going to work with very many cubic functions. We're never going to work with quartic and quintic. Okay? We've already done a ton of work with linear functions, and we're going to start doing a lot of work with quadratic functions. Okay? But we're not going to do that much more with quartic, quintic, or cubic. It is important to know what the degree is, and you need to be able to identify it by its number of terms. Okay, so how would I classify this first one? There's two ways, by its degree and by its terms. So what's the degree of this one? The degree is 1, which means I call it a what? Not constant. Constant is 0. Linear. So this would be linear. And then how many terms does it have? 2. So that means it's a binomial. All right, what about this second one? What about B? Quadratic. Because it goes to the degree of 2. And then how many terms does it have? 3. So it's a quadratic trinomial. All right, and then last but not least, this one goes to what degree? 7th. Do we have a name for that? 7th degree. So it's just 7th degree. And then polynomial. 7th degree polynomial because it's got more than 3 terms. Okay? So really the ones that you need to focus on are going up to quadratics. For this quiz and test, you'll need to know the words, but I won't really give you more than a quadratic. Okay, go classify these 4. So write them in standard form and then classify them. Standard form and classify, and classify.